So let's go on to lab exercise 2, where we are still trying to make confidence intervals, but instead of having numeric data, we actually have categorical data. So here, this is just yes or no or binary. So instead of having an answer be in the form of a number, then the question is actually answered with a yes or a no. A yes will be represented as a 1, and a no will be represented as a 0. Okay, so we can still input our data into R using a command like numeric data, just saying 0 means no and 1 means yes. Okay, so I have already popped that into R here. I've said, okay, I've got a new sample that I'm calling X, and all of these zeros mean no's, and all of these ones mean yeses. So when you're asking then how many people said yes, then all you need to do, because the zero plus anything is just the same as what it was before, all you need to do is just add up your sample, and all the adding is going to do is tell you how many ones there were. And here you can also use another command that's not sum of x, but also the length of x to tell you how many in total, both zeros and ones were there. So here, if I do sum of x, I see that there were 55 ones spread throughout. This sample, and when I say length of x, I find that there are actually 109 different instances of either 0 or 1. So the samples proportion would just be the number of successes divided by the number of total samples. So here I can find the sample proportion by taking the ratio of those two, and I can see that the sample ratio is there. So let me just catch up to what I'm supposed to be doing in web work here. So it says how many ones were recorded. I found that there were 55. And now I can use the central limit theorem formula for making a confidence interval. Here, if I want to be 97% confident, another way of saying that is I can have 3% error. So if I'm 97% confident, then I'm 3% unsure. And that is called the level of significance. So here I can find confidence by doing 1 minus significance, or I can find significance by doing 1 minus confidence. But here I'm going to pop all of that information into R, and then I'm going to use the formula here, this formula right here. I've just reprinted it in R, referencing each number by just saying I've saved these numbers previously. So here I can just use R as a calculator, and I can find both the lower and upper confidence level when using the central limit theorem. Of course, you can also use the bootstrap technique for proportions, as well as for um, means, or for categoric data, as well as for numeric data. But again, please have the Mosaic package downloaded, and then here also use the code that is being provided to you, so that your version of R and my version of R both get the same randomized samples. So here, after pasting this command in there and then finding both the lower and the upper quantile, the cutoff points, here, if I've got 1.5% in the lower tail and 98.5% in the upper tail, then what do I have in the middle? I will have the 97% that I'm looking for. Okay, so again, please, if that is mysterious to you in any way, please do go and look back at the lecture notes posted and the lecture videos posted into D2L to reference that. So here, just looking at this bootstrapped confidence interval, I am saying that I'm 97% sure that the proportion is in between zero point 0.4 and about zero point 0.6 here on the bootstrap confidence interval. And when I used the central limit theorem, it was a similar number. So notice that here, it is a slightly different number when I use the central limit theorem versus when I use the bootstrap. But for the most part, they are quite similar numbers, and they should be. Okay, so what I am saying is that I am 97% sure that the proportion is really in between 40% or zero point 0.4 and 60% or zero point 0.6. So the question here is saying, okay, a figure recently quoted by the Student Union was that it was 30%. Does your data support that statement? And here, our data is saying that it should be between 40% and 60%. However, 30% is not in between 40% and 60%. So in this case, we would say no, it looks like the Student Union's claim is not supported because our interval does not capture the value zero point 0.3, oops, zero point 0.3, which was the value that they were saying it was. We believe, we're 97% sure that the value is in between 40% or zero point 0.4 and 60% or zero point 0.6. And that interval does not include 30% or zero point 0.3. So we would say that that claim does not appear to be supported.